Welcome to Mr. Chalk's Revision Tips. In this video, we will look at alpha radiation, beta radiation, and gamma radiation. Nuclear radiation comes from the nucleus of a radioactive atom. In a radioactive atom, the nucleus is unstable, so it emits particles or waves while it forms or breaks down into a more stable atom. This process is called radioactivity. So there are three types: alpha radiation, beta radiation, and gamma radiation. Alpha radiation consists of alpha particles. An alpha particle is identical to the nucleus of a helium atom, so it comprises of 2 protons and 2 neutrons. It has a mass of 4. It is highly ionizing because it's relatively large, so when it goes and hits an atom, it can go and knock electrons off it or knock neutrons out of the nucleus of that atom. Because it's so large, it is stopped by air, it has a charge of +2, and it is slightly deflected by a magnetic field. So alpha particles, beta particles, and gamma rays are types of radiation. Describe the structure of an alpha particle. The way that you would answer that, simply, an alpha particle is made of 2 protons and 2 neutrons, and it has a charge of +2. What happens to the structure of an atom when the atom is ionized? So that's when something loses or gains electrons, so thereby giving it a charge. Beta radiation consists of high energy electrons that are emitted from the nucleus. These electrons have not come from the electron shells or energy levels around the nucleus. Instead, they come from a neutron breaking down and turning into a proton. As the neutron does that, it emits a negative beta particle in the form of a high energy electron. So beta radiation, because it's a high energy electron, effectively has a mass of 0. It is ionizing, but not as ionizing as alpha radiation. It is stopped by a few centimeters of aluminium, and it has a charge of -1. And it is highly deflected by a magnetic field because it is so small. So if we were looking at describing the structure of a beta particle, quite simply, a beta particle is made from a high energy electron and it has a charge of -1. Gamma radiation is a short wavelength that has a high frequency. It's similar to other types of electromagnetic radiation, such as visible light or X-rays, which can travel long distances. Like we've just said, it's a high energy wavelength. Because it's wavelength, it has a mass of 0. It isn't ionizing. However, it is stopped by a thick layer of lead, so it takes a lot of lead to absorb it. It has no charge, and because it has no charge, it is not deflected by a magnetic field. So if you're looking at describing the structure of gamma radiation, simply it's a high energy wavelength with no charge. Gamma radiation can also be used to kill bacteria on fresh food. Give one reason why farmers, shop owners or consumers might want food to be treated with radiation. So some of the things that you could answer is that it would give a long shelf life. The food could be supplied from around the world. It would open up wider markets to farmers. And because you're killing the bacteria on it, you are less likely to get food poisoning from that food. The diagram shows what happens when radiation from 3 radioactive substances pass through different materials. Choose the type of radiation and complete the table below. So have a think about how you're answering that, then go and look at the answer. So A would be beta radiation, B would be gamma radiation, and C would be alpha radiation. A detector and counter are used in an experiment to show that a radioactive source gives out alpha particles and beta radiation only. 2 different types of absorber are placed one at a time between the detector and the source. For each absorber, a count is taken over 10 minutes and an average number of counts per second is worked out. Explain how these results show that alpha and beta radiation is being given out, but gamma radiation is not being given out. So have a think about how you would answer that, then go and have a look at the answer. So alpha radiation, so the count rate is greatly reduced by card, or the card absorbs the alpha radiation but not the beta radiation. For beta radiation, the count is reduced by the metal, or the thin metal absorbs the alpha and beta. And gamma would pass through the thin aluminium. However, there is a very, very low count for what passes through the metal, so therefore it is unlikely that any gamma radiation is being given out. Thanks for watching.